Good morning, everyone. Before we start, I should like to make an announcement regarding yesterday's visit to the Acropolis Museum. During the guided tour, you had some headsets. So a few of you didn't return these headsets, and we need you to do this until 12 o'clock, let's say, because it's very important to be returned to the museum. It's an important equipment, and they need it for future tours. So thank you for this. And now let's start with our roundtable 1, entitled "The Role of Science and Society in the One Health Approach: How easy are scientific solutions to be implemented in practice and adopted by society and government?" You already know the One Health concept that recognizes the human health, animal health, and environmental health, and the close interconnection between all this. So the scope of this roundtable is to address the challenges that occur from emerging diseases, climate change, and the mitigation through sustainable production systems that requires collaboration across many disciplines and the effective communications between science, policymakers, industry, and the society. To introduce you to this topic, it's my pleasure today to welcome our keynote speaker, Professor Theofania Tsironi. Dr. Tsironi is an associate professor at the Agricultural University of Athens, specializing in food engineering, food packaging, quality, and many, many more aspects. Today, she will present you her lecture regarding safe and sustainable by design, translating food science innovation into food industry practice. So, welcome, Professor Tsironi.
Thank you very much for the introduction, and good morning, everyone. I selected this title because it's a nice bridge between the innovation achievements, the scientific achievements, and the real applications. And I will present you this safe and sustainable by design approach that recently is an emerging issue in order to bridge the gap between the scientific innovation and the real world application. But from my part, from my perspective, which is food packaging. But first, before starting talking about new product development and new packaging solutions, we need to address the issue that we face in food science. We all know that currently large amounts of waste are, large amounts of food are wasted in the food supply chain. One important cause of food waste is expiring best before date before the consumption level. It has been estimated that more than 30% of the produced food is discarded at different stages from production to the point of consumption. Of course, we can all understand that when we determine food waste, the amount of waste that we measure is just the tip of the iceberg. When we consider the food waste, we should also refer to the environmental impact. The increased costs from the raw materials that are lost are wasted. And of course, the fact that food loss and waste is an important ethical issue, as according to FAO, the annual food waste could feed the world's hunger 4 times. In order to mitigate the amounts of food that are wasted or lost in the supply chain, several actions have been proposed. One of them refers, according to FAO, to the improvements and optimization of food preservation and packaging technologies. In this talk today, we will focus on the food packaging approaches. Let's see what food packaging is. This is the packaging is the container that covers, protects the food, and it is also the process of packaging. the process of placing the food inside a container. Packaging performs two main functions in the food. First of all, the protection of the product to a predetermined time, the expected shelf life of the product. It also has another function, which is the advertising of the product, the labeling and advertising at the display point. Of course, food protection is the major function. But however, the consumer attention, the product identity remain of highly importance for the sale, and often packaging plays a key role in the selection of the final product. We have several innovations, several emerging issues in the packaging sector. Currently, joint efforts by the packaging, by the food industry, aim to reduce the amount of petroleum-based polymers. We have the recent European legislation that accelerates the plastic reduction and supports the recycling of the plastic waste and the use of biopolymers when they can be applied. On the other side, edible packaging systems can be used as thin layers or in order to wrap the food products, aiming to extend the shelf life or to reduce the required amount of plastic for the adequate preservation of the food. And these new packaging approaches need to be at the same time safe and sustainable. This has been under a very systematic framework. The packaging sector has adopted the Safe and Sustainable by Design framework that has been developed by the European Commission to assess the safety and the sustainability of chemicals and materials. In this approach, we have integrated the human health, the environmental sustainability, and the material functionality from the very first steps of process design. What we need to consider, first of all, the safety. First the safety, and then the sustainability and the suitability, the performance of the packaging materials. In this approach, in the Safe and Sustainable by Design approach, we first assess using migration predictive models, and by applying the worst-case scenario for the exposure of the consumer to the different potentially toxic compounds. And we consider, under this context, the move from the conventional testing of the product to the final, to the risk-based design. So we do not assess the safety of the product at the end of the production, but we validate the safety of the product because we have designed this way. And I'll show you some examples for new packaging solutions from our, for our team and collaborations within the different groups at the Agricultural University of Athens under the Safe and Sustainable by Design concept. Focusing on the packaging, and in order to effectively design alternative packaging materials, first, we need to consider the raw materials that we use. Currently, we have extensive research that is carried out in order to valorize the waste for the production of either biopolymers or bioactive compounds for the food packaging applications. Here we see some applications, some examples of development and application of alternative packaging materials by valorizing, for example, fish bycatch, fish protein concentrate obtained from fish bycatch, by valorizing sunflower protein isolates, legumes, or by sugar beet pulp. But we need to consider the safety, first of all. We consider the functionality, the performance, but we need the compliance of the packaging materials in terms of safety. This means that we need to prove the compliance of the of the packaging material and the safety of the packed food product in order to be consumed. This means that the migration of potentially hazardous compounds be systematically evaluated and at the same time mathematically modeled in order to assess the safety. We need advanced analytical methods to determine total and specific migration in order to evaluate the compliance of the packaging materials. And we need to systematically evaluate the migration because migration is not a static phenomenon. This is a time and temperature dependence. It can be affected by the packed food, the composition of the packed food. For example, the high lipid content accelerates the migration. It accelerated by increased temperatures, and in some cases by increased relative humidity. This means that for designing an effective packaging material, the intended use is very important. Temperature and relative humidity can be translated in the storage conditions. For example, if the food packaging will be applied on a food product that will be stored in the refrigerator, where temperature is lower but relative humidity is higher, or in the shelf. EFSA and the national authorities apply standardized migration scenarios. They simulate worst-case scenario depending on the food shelf life and the storage conditions in order to be sure that the packaging materials will be adapted by the food industry in a safe way. Another issue when we consider migration is the assessment of the toxicity. We have the new regulation, the PPWR, Food Packaging and Packaging Waste Regulation, that defines the migration and the toxicity as a very important issue that needs to be mapped, characterized for all the available packaging materials. But the regulation doesn't give us the means to do this. It doesn't provide an appropriate or a standardized methodology to assess the toxicology. We have new packaging materials, and new materials mean new uncertainties. So we don't have the NIAS or the specific migration compounds that needs to be assessed in order to evaluate the safety. Based on this gap, we recently proposed a protocol based on an interdisciplinary approach, combining knowledge from biotechnology, cell biology, engineering, food packaging technology, for the comprehensive assessment of migration and the safety of packaging materials. In this interdisciplinary work, we have collaborated, our team from the Food Science and Human Nutrition Department, the Laboratory of Food Process Engineering, together with the Laboratory of Molecular Biology, Dr. Kaliabakou, represented by Dr. Kaliabakou and Professor Flemetakis. At the same time, we have a safe packaging material, but it should be also protective for the food. This doesn't mean a safe packaging material doesn't mean that it will protect the food for the predetermined time. We need to have safe packaging materials, but we need also to retain the shelf life of the product at least at the previous duration, at the duration it has for the conventional packaging, for example. In most cases, the natural polymers, the biopolymers, do not provide the necessary protection in terms of moisture, gas barriers, mechanical strength. We have several approaches that are currently proposed, for example, appropriate coatings to enhance the barriers or the incorporation of bioactive compounds to provide extra protection to the food. And in order to adequately preserve the food, we need to know very well our product, the food to be packed under this specific material. We need to consider the exact spoilage mechanism of our food. if we are the producers, the food producers, we know our product better than anyone else. So an effective packaging solution is tailored to the specific requirements of our food product. We need to understand the food quality deteriorating factors that we aim to inhibit in order to effectively preserve the product and extend the shelf life. On the other hand, overpackaging sometimes has been observed in several cases and different applications, as for example, these peeled bananas that are packed in a plastic tray, covered with a plastic lid, and protected by modified atmospheres. This is a very classic example of overpackaging for a product that doesn't really packaging at all. So we need to be sure that we address exactly the spoilage parameters of our food product in order to adequately preserve our product and avoid overpackaging. Under all these contexts, I will show you some examples with applications of alternative packaging materials that can either replace or supplement the conventional packaging, but effectively preserve the food. Here is an example with the application of chitosan-based edible coating on fish fillets, which delayed microbial spoilage, improved the appearance, and extended the shelf life of gillhead sea bream fillets by at least 3 days at 2 degrees Celsius. In this coating, we have also incorporated a citrus extract, which has been approved for food applications, in order to further extend the shelf life by as an additional hurdle in the preservation of the food. This is another example of active packaging systems, which is presented for whole tomatoes. This work was carried out within the project through algae that was coordinated by Professor Flemetakis. We developed active edible coatings for whole cherry tomatoes, and at the same time, an active pad that was incorporated inside the package and released volatile bioactive compounds, for example, essential oils, and in some cases, microalgae extracts, in order to effectively preserve the tomatoes and delay microbial spoilage. Here is another study that is directly connected with EU-CONEXUS, so I'm very happy to introduce you this approach. Here we have developed a novel packaging system by incorporating a marine bacteriophage into natural biopolymers, natural biopolymer-based coatings, I would say, that were applied on oysters for the inhibition of the growth of Vibrio alginolyticus in case of contamination and the extension of the shelf life. This work is connected with EU-CONEXUS because it was carried out during the training and the thesis of Ms. Staphili that had the presentation the first day, and it was co-supervised by myself and Professor Flemetakis. And the last application that I would like to present you today is the innovation of smart packaging in the food sector. Intelligent packaging is an approach that can provide information to the users regarding the quality status of the food. Here is an example of a freshness indicator that gives you information on quality directly. Why it gives you a direct information? This is a label that contains a pH-sensitive dye that monitors the production of biogenic amines in the headspace of packed fish. And this color change, the response of this label, indicates loss of quality, and we can calculate then the remaining shelf life of the product at any stage of the supply chain. This label is developed within the PhD of Ms. Bazdeki and received a grant by the Hellenic Foundation of Research and Innovation. And why this is an issue that is important to be applied on perishable, on sensitive food products. Considering that the temperature conditions of the real cold chain, especially in perishable products, sometimes deviate from the recommended range. And since the temperature is one of the most important factors that affect the microbial growth and the quality parameters of the food, all these temperature fluctuations that occur in the supply chain affect significantly the quality and the shelf life of the product. This issue highlights the need to provide to the users clear indication of the quality level of the product and effective cold chain management. So according to our research, these smart labels can be applied in a complementary way to the conventional use-by date. It will not replace the use-by date, but it can support the use-by date in a protective way for the consumer with an indication such as use by the 20th of June, unless the label is red. The overall effort and the take-home message is to bridge the gap between the plastic reduction and the food waste reduction by new material development and packaging system optimization. Thank you very much.
Thank you very much, Dr. Gironi, for this insightful presentation. I can see that you've highlighted the importance of how we bridge the gap between scientific knowledge and real-world implementation within the One Health framework. Does anybody have any question from our guests today? Okay. Since nobody has a question, I'm going to ask a few questions.
We have one question.
Who?
To be honest, this is a very critical issue. How could the end users, the consumers, could handle with these color changes? The main issue from other studies that we have also implemented an extended consumer study on this approach. The main issue is that sometimes the consumers are really confused about the use by and the best before date, actually without the presence, without the incorporation of smart packaging. So we need first to educate the users on this approach. And the most important issue is not the fact that we have the expiration date that has passed, but the label is green. This means that it has to be appropriately packed, stored. Because, you know, the main issue is that when we define the shelf life of the product, which is under the actions that should be taken by the producers, there is no regulation regarding the shelf life. We have the regulation for the labeling, but not for the estimation. And another issue is also that we do not have a harmonized approach regarding the reference temperatures for the calculation of the shelf life. So we have it depends on the producer, or the approach that some countries can have from national guidelines, but not regulation. So we have the approach that is more conservative. So we say that our product, if it's a fish product, we'll say, let's say, okay, it should be stored at 0 to 2 degrees C, and the shelf life is 7 days, I will place 7 days in the packaging in order to pursue the stakeholders to retain the temperature low. On the other side, we have the other approach that says, okay, I will assume that the main temperature will be 5 degrees C, and I will place on the package 4 days. This is very restrictive because you cannot export, but on the other side, if the product is adequately stored, you will discard the product that's of high quality. So this issue is the most important, and regarding the confusion of the consumers, the main issue is the intermediate color changes. So everyone will search in the supermarket for the greenest label. So this is something that needs to be addressed. Maybe first it can be applied up to the logistics level and not to the consumer, or until we educate the consumers in this way. But this is very critical, and to be honest, BioMinion, this is the main issue that these labels up to now have not been extensively applied. Thank you very much. It depends on the how rapid is the color change at the end of the shelf life of the product. We need the chemistry, the design of the label to be this way that it accumulates the time temperature burden without indicating a color change. We need in the color change a long plateau, but accumulating on the back, the burden, this handling, the time temperature handling, and then have a rapid change in the color that can be visual, but in this way that it needs some hours, for example, and not some days to give visible evidence. This has to do with a labeled design and chemistry on the background. Yes, this is something to be optimized in any case. No? Up to now, we have already edible packaging systems. So from the perspective of coatings, we have all these fruits placed on confectionery products, that are wrapped. I would say covered, not wrapped, with high concentration sugar or carbohydrate coatings, to preserve the color and the moisture level of the product. This is a conventional and well-established edible coating on products. For edible packaging, which can be, for example, a film or a cover, or even an edible food contact material in general, a cup or a fork or something, this is something that needs to be further discussed. From our part, we have not evaluated the edible nature of the products in terms of, effect on human nutrition or something like that. But we, from our part, handle these edible materials as potentially edible, but in any case biodegradable materials. This is the aspect up to now. I guess that will be more difficult to go this way, but the biodegradability, since they are edible, they are biodegradable, so it's much more relevant for a bio-based packaging.
So
Because from August 2026, we have the PPWR that gets into action, and we will we will evaluate the recyclability of the packaging materials. So we need more bio-based and more environmentally friendly approaches. This biodegradable packaging, in any case, cannot completely replace conventional packaging because we cannot, using these materials, effectively preserve the food. But we can reduce the required amount of plastics. So this is the main approach, compliance with the new regulation, plastic reduction, without compromising safety and shelf life of the product.
So we can see that many solutions exist, yet their implementation remains challenging. So to explore how these challenges are viewed across different disciplines, I invite Dr. Chironi to join the discussion with our distinguished panelists. Our panel today brings together experts representing environmental biotechnology, crop genetics, biodiversity conservation, artificial intelligence, and psychology. So this diversity reflects the interdisciplinary nature of the One Health concept and will allow us to explore the topic from multiple perspectives. Now, I would like to ask our panelists to limit their initial responses to approximately 1 minute. And I would like first to hear from each panelist how the One Health concept connects with their own field of expertise. Our first panelist is Professor Dimitris Vlachakis from the Agricultural University of Athens, an expert in genetics, bioinformatics, precision medicine, and translational research. Professor Vlachakis advances in genetics and bioinformatics, transforming the way we understand health and disease. So from your perspective, what is the most promising scientific solution today that could significantly contribute to the One Health approach? And what is it preventing its wider implementation?
Right, thank you very much. There is no way I can do that in 1 minute, so let's start, let's take our time. There is no better place to discuss about One Health. You will not find a better place in the whole world than this place, not this place in Technopolis, but this place in Greece, in Athens. And I'm going, since we are open to interaction with you guys, the audience, I'm going to ask you this question. If you go to literature and scientific literature and you look for the term One Health, you will see that in the last few years it has skyrocketed exponentially. Too many articles come, they spawn out of nowhere, and there are too many articles about One Health. But how old the concept of One Health really is? Do you have any idea? Does anyone know when the concept of One Health was firstly introduced? It was about the first time that we know the concept of One Health. It was not named One Health, but the concept of One Health was about 2,500 years ago in this place by ancient philosophers and doctors like Asclepios and Hippocrates and Galinos, who said they brought the idea that it's better to prevent, to remain, it's better to act towards staying healthy than curing a disease. So in this place now we have the concept of One Health, and we try to link environment and nutrition and food science, food safety with medicine. And that is a huge challenge because One Health is an entity, is one solid item. And in order to do that, we don't need to think how we can improve those three elements, but how we can blend those two into an entity. And I think that the solution to that is AI, is artificial intelligence in our times, because One Health, from a technical point of view, is not an environmental or a medical or a food science problem, is a data integration challenge. How people from different disciplines can get together and communicate using the same language, because we have standardization and harmonization problems in science. We use the same terms, but from different backgrounds, we mean different things. So I think that AI will play a pivotal role in the future and will be the connective tissue that will bring everything together into one entity, into one vector that can be really translated into real health in the society, because we know that One Health has to do basically with prevention. We are healthy and we want to remain healthy for as long as we can. Longevity is another issue, because the life expectancy has increased. Now we live longer, but do we live better? We know that we have extended the lifespan of human beings for a few years, but we also know that the last 12 to 15 years, we are really sick. We are not very well. Dementia, cancer, immune diseases. People live longer, but the quality of life is not that good. And we need to take action towards improving the quality of life as well, not just the quantity of life. And I think that is the core of One Health, that AI will try to seamlessly put together. And in the next couple of years, I think we're going to see wonderful things coming up by harmonizing and standardizing the different vectors within the entity, the concept of One Health. Thank you.
Of improving health quality and the relation with One Health approaches. So building on this perspective, I would like now to turn the discussion to crop resilience and food security. So next we have Professor Nazgul Emrani from the University of Rostock, whose work focuses on crop genetics, climate resilience, and the development of stress-tolerant crop varieties through modern genomic approaches. So, Professor Emrani, how important are crop genetics and breeding in secure future food production within One Health framework, and particularly under the pressures of climate change?
Yeah, well, thank you very much for giving me this opportunity to be here today. I think crop genetics and breeding is fundamental when it comes to the One Health concept, because crops produce food for us, and food systems are basically sitting at the intersection between human and animal health and environmental health, and also economical prosperity. So I think this is absolutely important, especially looking at the situation with the climate change today. Due to climate change, we have problems with drought, with salinity, with some pests and diseases that maybe were not problematic a few decades ago, but now they can propagate better and they can infect our crops. And I think the solution to this, one of the most efficient solutions to this, is to develop resilient crops. And that's what, for example, my group is working on. We are trying to improve the abiotic and biotic tolerance of the crops. We want to basically use crop varieties or develop crop varieties that can better use resources. For example, higher nitrogen use efficiency is a target, and that they can be more healthy even in times of drought, salinity, or heat that we are dealing with, unfortunately, more often today than before. So I think, crop genetics has a very good perspective in this aspect. Yeah.
Thank you, Professor Emrani. While crop genetics provides long-term solutions for resilience, innovative biological inputs can also help us adapt to environmental stress in a more immediate way. So we are also pleased to welcome Ms. Marie Harafik, whose research focuses on algae-derived biostimulants and their role in enhancing crop resilience and sustainable agriculture. So Ms. Rafik, algae-derived biostimulants are increasingly recognized as sustainable tools for improving crop performance under environmental stress. In your point of view, what is needed to accelerate their adoption by farmers and agricultural stakeholders?
Hello, everyone. Thank you for the opportunity to speak on today's panel and discussion. So I believe that the restrictions we might face in promoting bio-based and also algae-derived biostimulants, to be very specific about them, are three very, very crucial parameters that are like precise technology that is reliable and is available in terms of farmers' confidence. I know that the technology is sustainable, but farmers do not want to, just adopt the technology for the sake of their sustainability in the environment and the climate change. They also want some concrete evidence that have a very strong performances in the field assessments. So we need to develop the technologies that provide such kind of solutions. So this is where my research aim comes in. It's regarding to create a multi-omics and digital twin approach to see whether how the algae-derived biostimulants perform in the stress environments. And this is to integrate all the data in a digital twin so the farmers are able to see into the data and can adopt to these technologies. So for me, it's very, very important that the technologies we offer to the stakeholders also, because stakeholders are more interested in terms of profitability. So, and farmers want to have something that has precision, that has reliable performances in the fields. And yes, so it makes the farmers have more confidence in using that technology because of the concrete evidences that can be provided in such AI-driven and integrated systems. So yeah, that is my thinking about on it. Thank you.
Thank you, Ms. Rafik, and thank you for pointing out that agricultural production does not exist in isolation. And this gives me the point to say that agricultural production depends heavily on healthy ecosystems and biodiversity. So we are also joined by Professor Lukas Kalous from the Czech University of Life Science in Prague, an expert in fisheries, aquaculture, biodiversity conservation, and aquatic ecosystem management. Professor Kalous, healthy ecosystems are a cornerstone of One Health. What are currently the greatest threats to aquatic biodiversity, and how do they affect human well-being?
Okay, thank you. Thank you for being here, having me here. There is a myriad of activities of humans, and maybe in relation to One Health. So maybe I will bring a perspective that we should, in a particular activity, always care about the consequences, because we may have a lot of good intentions to do something for a good, for something which bring prosperity or some well-being for people. But many of these intents can be, what is said, like the way to hell can be paved by many of the good intents. So just to have or to see the connectivity is very crucial. And from my perspective of, let's say, the freshwater ecosystems, so there are something like a veins of the landscape, and everything what we do in the landscape is later on reflected in freshwater ecosystems, because they cover quite a small part of the land. And so the question followed by what are maybe the main crucial activities which threaten these ecosystems. So it's of course the pollution. So every pesticides which we use, so they end up in the water and later on have the impact on that. So nowadays we face of course, the droughts and the changing of the environmental, climatic conditions, which, of course, change the processes in ecosystems and freshwater ecosystems, and not only, of course, freshwater ecosystems everywhere. And what is the game changer nowadays is, of course, like as we transport animals and plants all over the world. So sometimes we bring also these non-native species, and some of them become invasive. And if they become invasive, so the invasive means they have some kind of impact, and so they really can be game changers for energetic flow in these systems. So yeah, so that's my answer to your question.
Thank you so much. Exactly. Mitigation to climate change needs many times technological tools and data-driven decision making. So our next panelist is Dr. Philip Ree, head of the Bioeconomy and Smart Farming Division at the Fraunhofer Institute. His work combines digital agriculture, artificial intelligence, and sustainable production systems. So, Dr. Ree, how realistic is to expect AI-driven solutions to accelerate One Health implementation in agriculture? And what are the main barriers for their adoption?
Yeah, so this is something we're dealing with quite often. So we are, as Fraunhofer, not an organization that is doing research like in the university, but we are, our sweet spot is the transfer to the industry. So it's often the question, is that actually has an impact? Or is it sometimes also just a nice idea, but eventually nobody cares about it? Or it just does not fit into the picture. Maybe like there's one example, we are, out there, especially with AI or so many good ideas coming up, and sometimes also people are very much convinced. For instance, we had a technology, or we still have that, where we can track the heartbeat of a cow by just using a camera. You can also do it with humans. You can track the pulse of a human by just having a camera focusing on the lips, and then you retrieve the signal. And then we also discussed with people from the industry, wouldn't that be a great solution? And then also they were curious and said, okay, but eventually we came at this point that nobody cares about. And it has no management implication. And we often come to the point that we are thinking about great ideas and also being convinced, but we communicate too late with the industry. And also we need to be open to kill your darlings, to then focus on technology that actually has an impact. And it's not just a good puzzle piece, but fits into an entire solution. There are so many stakeholders involved to get a technology into practice, and it's not just the idea of one smart researcher. That's not.
Exactly. Technology can help us address complex challenges. However, successful implementation ultimately depends on human behavior, public acceptance, and society's willingness to embrace change. Finally, we have Professor Zvezdan Penezic, Vice Rector of Science and Information Infrastructure at the University of Zadar. His research focuses on personality, well-being, and health-related behaviors. Professor Penezic, throughout today's discussion, we've heard about many scientific and technological solutions. Yet, implementation often remains difficult. From a psychological perspective, why do people resist change, even when scientific evidence is strong?
Well, thank you for the invitation here. Well, this is a hard question sometimes to answer, this resistance to change, why people seeing lots of better things and we are resistant to them. But also, according to psychological science, we can find few answers, possible answers to that, starting from, let's say, combination of psychological economic research, where we find that, let's say, psychological loss has the more impact, twice more impact on behavior of the people than gains. So people are afraid of losing something or something which is a routine to be lost, and will take our place on the other on route already found it. Also, the cognitive cognitive dissonance. When we have this, we are resilient to any change, and experts' opinions produce the contra behavior. So we behave against the experts or something what they talking about, and also maybe identity treat when we are expected and we find some way to function on right, and any change to our behavior, any change to our route, it's something change our routine, change our nice behavior, and we don't want to behave in that way. So, but there is a possible ways to investigate more in new way, talking about these health behaviors, and we have lots of research in the future about expecting to be done, especially in this One Health area.
Thank you, Professor Panisic. We have now heard perspectives ranging from biotechnology and agriculture to biodiversity, digital innovation and psychology. Well, I was planning to do 2 or 3 more questions, but in order to be on time and to have a more interactive discussion at the end, I will move on to my final question, my final round, and I will have to ask each one of our panelists, what is the single most important action Europe should take in the next 5 years to strengthen the One Health approach? Let me start with Professor Vlachakis.
Okay, it works. Europe should chill out a little bit. I don't think that it takes a genius to understand that we all want to stay healthy. We should keep it simple, keep it straightforward. There is a need for common sense, and I think that what we do here is exactly what should be outlined in all the policies in the next few years about One Health. We need to be connected, we need to stay together. As I said, I have a favorite quote from Aristotle, who says that the entity of the potential of the entity of one system is much greater than the potential, the power of the components of that system if you break them up and you fragment it. I think that the solution is what we do here. We collaborate, we unite, we exchange opinions, we remain true to the science and the ethics of science, and then we move forward. And I think that the next few years are going to be very, very important, and action should be taken soon. But I'm very optimistic. I think things are going to go, at the end, it's going to be a win-win situation.
That's a very optimistic perspective. Professor Emrami, what do you think?
Yeah, so I think what we need, and what I hope that the European Union would support us with, is an interdisciplinary approach. So it's not only bringing different scientists from different fields together, but we also need to have representative of the industry, for example, joining also, and also, you know, the lawmakers, the governmental agencies to also attend such gathering of scientists and discuss, you know, the potentials of different fields of science that we are advancing in. And I think the problem is not that much on the science, because I think in the scientific field we all can make a lot of advances, but the question is how you can implement that actually as a law or the rule in the future so that it can be used for everybody. And in my field I see it very clearly. There are a lot of techniques that have a very good potential, you know, that we could use, but there are resistances in the European Union, for example, when it comes to, you know, genetic engineering, maybe just one example, that we really have problems there to implement what we see maybe in our labs and in our greenhouses, so that have an implication for the society. And I understand that it's not only from the governmental point of view or the lawmakers, it also requires the acceptance of the public, of course. It has to be worked on, so representative of the public should be there also in such discussion. And yeah, I think we need an interdisciplinary approach in the future, for sure.
Exactly, not only stakeholders, but also scientists, governments, and many, many more others in order to have better solutions. What about the biodiversity point, Professor Kalos?
Oh, biodiversity point. I think what we need is the orientation in information, maybe. So the world is flooded by the information, and I mean, we heard a lot about AI and a lot of what we believe in, what the AI can bring, and of course it's a great opportunity, but it also brings a lot of other information which are not, I mean, let's say it's some kind of like wheat information which just is over, and yeah, so this is the orientation in the information in general. So what is really helping to biodiversity, what is maybe more just hobby activity, how the society perceive the state, and how they can deal with the information. And for that, I think we need also a kind of like leadership to communicate it with the society, which can be then united under that direction, which is then set up. Yeah, so I see the possibilities, but of course that will be challenging.
Okay, again, we heard about society, but what if someone had the power to remove an obstacle? What this could be, Professor Penezic?
Obstacles. I was just thinking about the previous answers here. There is obstacles should be reduced by maybe political will to implement all these changes. We have the policies. You mentioned policies here. The policies are defined, but that will to implement these policies and to educate the people to change to these activities. Sometimes thinking about that resistance to change is a result of the time gap. Let's say we have now talking about 5 years period. You ask about 5 years period, and talking about that the changes and let's say national levels or something reduced to 3 to 4 years. So no one wants to take this responsibility to change something because it's out of his range of activities. So we have just to make maybe these activities to introduce to the public, to introduce to the to educate the people about these possibilities, and to press to the, let's say, to maybe political levels to implement that without taking responsibility for this, without expecting some that their responsibility is something that will change. Something it's very hard to answer that, but I think there is a need for implementation. Then these policies we define very right.
And from the side of digital solutions, Professor Ree?
So for the side of digital solution, I think there's regulation is good to have in place. But what I definitely see is that we need to, it was named interdisciplinarity. It also can be thought of transfer, so then we measure success of research not just in publication and funding, but also in terms of impact it has. And I think then it should be demanded that there is a link with other disciplines or with other stakeholders, and especially that also young researcher being trained to early communicate with a policy level, with industry partners, and not just staying in the bubble. I mean, it has been said here. It's also I haven't seen anybody from research, from the industry or from policy side. That does not always have to be, but I think it showcased a little bit like researchers or anybody like to stay in the bubble, and we should break that.
Exactly. And from the researcher side?
For me, I think that the main obstacle that is happening is because science is so complex, and we need to make it available to the society, and the end consumers is the simple people. So the science is too much very complex for them, so we need to do something in the area, which is a huge opportunity to make it simple and also available for the society people. So yeah, thank you.
Thank you so much. And Professor Cironi, what do you think is the bottleneck from your side?
From our part and from my research area, the main bottleneck is the gap between the research, the scientific innovation and the real-world implementation in terms from the time required to ensure safety, compliance, the regulatory aspects, and the consumer acceptance, and the societal benefit in general. This delay is not a drawback always, because in some cases we need the time, but the translation of the science into real-world applications is something that needs to be more implemented by involving more opinions, more stakeholders, not only the scientists, but also the stakeholders, decision makers, policy makers, and of course the end users when they are the consumers.
Thank you, Professor Cironi. And now I would like to ask the audience if they have any questions for the panelists regarding all the One Health approaches and aspects we discussed today. Any questions for the panelists? Okay. So maybe...
general statements, but we're not getting practical voice to what the issues are. And I'm wondering if people may have some comments about what your individual concerns are, or where people are with their struggles in One Health. Of course there's diversity, but if you just might have any more direct thoughts about the problem and the solution that you'd like to see addressed.
Professor Cironi.
This is more or less, from my perspective, what I answered in the previous question, the difficulties to translate the experimental data into real applications. And we need to involve in this discussion several different approaches involving all the stages, from the scientific innovation up to the application. So the policy...
This thing is that we keep those problems not as obstacles. We don't see them as obstacles, but we see them as scientific challenges that can help us promote progress and make new discoveries in the field of One Health.
And since we are talking about the multidisciplinary perspective, the crop resilience is also very important, and Professor Emrani has a comment also on this.
Yeah, thank you for the question. I want to maybe address the question from my point of view, from the point of view of crop genetics and breeding. Do we know how long it takes for a new variety to be released in the market? How long does it take for a variety of wheat or barley that is developed for a certain trait, for example, to have a higher yield, to have a good disease resistance, for example, how long does it take for this variety to be developed and to be released in the market? Do we have any idea? Minimum 10 years. So if you think about developing a new wheat cultivar, and you start today, because you think at the moment drought is a big problem and I want to develop a cultivar that is drought tolerance. If I start today, my cultivar is earliest, and this is the earliest, on the market in 10 years. Sometimes it takes up to 15 years. By then, maybe drought is not a problem anymore. Or by then, maybe a certain disease that I'm breeding for at the moment is not a problem anymore, because the environment has changed so much that that fungal disease is not important. So when we think about solutions, we have to also consider that there are some knowledge gaps also in the society. So people think, oh, why do I need, for example, genetic modification of the crops? They can do breeding. They have been doing breeding for years and for centuries, so they can just continue. But we do not understand that the process of breeding is a very long process for one-year crop like wheat and barley. I don't want to talk about trees and some other type of crops. So this is really an issue that we have to first understand. And if we understand it, then we realize, okay, if there are some methods that can accelerate this process, that it does not take 10 years anymore, but maybe 5 years or maybe 4 years, then maybe they are beneficial to be implemented. And I think because many of us are not aware of those challenges, then we can't really follow why it is necessary to make some changes. And in my perspective, the communication, as was mentioned here, with the public is also very important, so that we discuss, okay, what are actually the problems in every certain field and how we can address them.
Exactly, and innovative solutions such as biostimulants are in close contact with crop resilience. So what do you think, Ms. Rafik, on this?
If I talk about my track of research, I would say that the track of my research is like at the end product is forming like a predictive model. So it is also that we conduct awareness programs and also training programs for the farmers, for the stakeholders, how to integrate that technology in their existing framework of procedures. So for me, that is, if I develop a specific product, it has to be communicated and to be understandable and be very easy to use for the farmers also. So it's making a complex science, translating into simple things. So I would definitely do that making predictive models that have different data sets involving for my interest in crops. Maybe they can be any crop, starting from the model plant and moving up to the complex agriculture crops that are very important across the world also. So what I would do, or maybe it's a very far-stretched idea, but making like a global library of the predictive model. So in one system, there's everything, and if you add an input, the predictive model can, predict and can give you outcomes on the basis of what the input it already had, and where the gaps, the system can, predict itself. So we can do it. I would do it with this approach. So yeah, thank you.
From a psychological point of view, though, how easy is to integrate all these approaches in the One Health approach? What do you think, Professor Benesit?
The hardest question now. We have so lots of discussion about the integration of this one, but I'm just thinking about this question. The problem is not in science. Science have the cumulative knowledge. We have to communicate that findings more intensive, that to communication. You ask about the definition of this One Health, about how that we have to communicate this one and to integrate all this. I'm coming to the first question. We have just to be less resilient to that changes, to educate people, to communicate it, and this is the role of the scientist, to communicate the findings of their research, not just the publish, to go to the public, to present to the more people than not just publishing in the scientific articles which read small number of the people, and the majority of the people all around us don't understand what we are doing here. So to communicate, and this is the main fact that in these interdisciplinary approaches we have to communicate together to find the best possible solutions, and these days we have lots of opportunities to communicate here between social science, humanities, even these natural sciences, and we find lots of ideas which could implement together. But it takes some time, but there is opportunities to communicate, and the communication maybe is the crucial moment here to communicate these activities.
Exactly, because resilient crops, biostimulants with microorganisms, drone technologies, all these make the general public to be afraid of all these technologies. And maybe this has also an impact at the biodiversity part. What do you think, Professor Kalos? The general public is going to accept all these technologies?
So, I think general public is happy of seeing new technologies, of course, always. And yeah, I mean, maybe I was stuck what was already said here, so that the knowledge is present, but the decision then is based on particular interests, and that must be communicated, and that's maybe the gap, which is always what we struggle. Maybe, and just it came to my mind, how long does it take to bring some crop to be planted on the fields? There is also a history which we need to understand. This in the case of ponds, so they reflect the history which happened. The mistakes which we did with a lot of chemicals which were used on the agriculture fields, and then they are now deposited in the sediments. And people usually want quick solutions, but to understand what is the reasons why the one ecosystem of the pond behave in that way. Of course, it needs information, then compared to knowledge, and then to make some decisions and communicate these decisions. Why we have to change, for example, some of the management in fish production. And of course, again, I can connect this to what was said by Professor Peniežič, because the people they want quick solutions, and we need to explain them. And if they don't explain that, so then the actions will not be taken. So that's my comment on that.
So today's discussion clearly demonstrated that One Health is not only a scientific challenge, but also a societal one. Scientific knowledge, policy, industry, and public engagement must work together if we want to have innovative solutions to create real impact. So thank you all for your valuable contributions, and thank also the audience for joining us today. I think we could move on to the next session now. Thank you all so much for your participation today.
So this workshop is dedicated to 2 of the 6 challenges that were created under EU-CONEXUS community: sustainable disease management and ensuring healthy soil, healthy food and soil. Our agenda for today is structured this way. Purpose of this workshop and the role of PDSO. I will share with you some insights regarding project development and support office. Overview of Horizon Europe. This will be a really short overview regarding this important funding call. Presentation of the 2 challenges that are specific to this workshop. Some live activity to get to know each other, find out more things about each other, what we have in common, or how could we support each other in eventuality of a proposal or future project. Presentation of the selected Horizon Europe topics. There were 3 topics that people registered for this workshop chose from the list we provided. There will be also a brainstorm on those selected topics. You will present your ideas, and we will close the workshop after about 1.5 hours that is aimed to be spent here together. Role of PDSO and the purpose of this workshop. So, I don't know how many of you do know about Project Development Support Office? Yeah, no, not so much. Okay, so it's one of the first transversal offices that were created under EU-CONEXUS community. It is established in the framework of EU-CONEXUS Plus funding, and its main overall objectives are to increase EU-CONEXUS capacity in order to win more European funds, to develop the capacity to build, exchange knowledge and expertise in terms of project development, and also to increase collaboration among partners and also enhance EU-CONEXUS community with regards to SMAC's challenges. Who is PDSO? Here are the members. Lucie Vossel from La Rochelle University. She is coordinating actually the PDSO office. Lea Ovillier and Lino Gruber. Lea replaced Lino for a couple of months. Adriana Sumunaru from UTCB, myself, Bianca Mătăsariu from UTCB also, Cristina Constantinidiu from Frederick University, and recently added Jessica Harrison from ECTU. Here are some activities that were developed under PDSO. Organizing and participating in trainings and information sessions in order to promote funding opportunities like blended intensive programs on EU funding and projects. Hi, join us. Support for matchmaking between partners. I'm sure that you or some of you already received several emails regarding matchmaking on calls that you were nominated to be suitable or you manifested interest in. Facilitation of collaboration between project development support structure of the Alliance through knowledge and expertise sharing. Management of the seed funding call. Internal call to develop small-scale projects, and also aiming to enhance collaboration. Some of the several achievements over the years of the PDSO office are 38 European projects involving at least 2 partners of the Alliance were submitted since 2022. there were 22 small-scale projects funded under a seed funding call. Around 800 people trained or informed about European funding opportunities. Also, there were enhanced network and collaboration between research support offices all over the Alliance. And another achievement was boosting to apply to specific programs in order to obtain funds. Why are we here today? When we designed this workshop, we had in mind to get together and became familiar with European's key funding program for research and innovation, Horizon Europe, also to activate the Alliance research community and to facilitate this engagement among the researchers under the EU-CONEXUS Alliance. A short overview over Horizon Europe with this type of funding. I'm sure that you are all familiar, so I won't be staying long here. Horizon Europe is one of the Europe flagship program for tackling global and societal challenges, and is designed to support mission-oriented and interdisciplinary and impact-driven research. So here, a strong focus is on expected outcomes and pathway to impact, and also having stakeholder relevance engaged into in the projects. The general frame for Horizon Europe, you will have on the left part a specific funding, specific program European dedicated to defense projects, and on the other extreme there is Euratom that is dedicated to nuclear research, and these two types of funding are not specific to EU-CONEXUS Alliance. Where we'll be focusing will be Pillar 2, dedicated to global challenges and European industrial competitiveness. Here, this pillar is structured under 6 clusters and another structure, joint research center. What we have in mind here is more like a recommendation. When you are taking the decision to apply for a funding, it would be recommended to think at forming a consortium. It's already condition mandatory for all the proposal, and the consortium should be formed by 3 independent entities from 3 different countries, and at least one should be from a country in European Union member states or associated countries, in order to be eligible for applying to have the funding. The proposal should be submitted via Funding and Tenders portal before the deadline, of course. You have to take into consideration all the compliance with the admissibility, eligibility, and topic-specific requirements. And of course, there might be additional conditions that you will need to take into consideration depending on the topic you choose to apply with. You will receive this presentation, and you'll have their resources, the entire Horizon Europe program, the entire framework for 2026 and 2027 that contains all the directions and all the topics with more details. And of course, another link with the Info Day sessions hosted by experts from Horizon Europe, and the European Commission. Those are really helpful if you need to obtain more information or be more clarified on certain topics. The two challenges that I was telling you about and are specific to this workshop. So under EU-CONEXUS, there were created some frameworks, joint research challenges, in order to provide this transdisciplinary challenge-driven research across the alliance, to bring together various experts in order to ensure this characteristic of possible proposals. And these joint research challenges are, like I said, strategic priorities grounded in the real-world issues and impacting coastal and urban regions. They are aligned with EU-CONEXUS vision for smart urban coastal sustainability, SMACS for short. They are designed also to enable collaborative impact-oriented research, and they are also a response to a need for co-creating knowledge with society. Based on the EU-CONEXUS researchers and their respective research activities, there were 6 SMACS challenges identified in order to address better the EU-CONEXUS researchers community. And these challenges are sustainable disease management, sustainable coastal waste management, ensuring healthy food and soil, protecting oceans, seas, and waters, adapting and mitigation of global climate change in coastal environments, and smart coastal infrastructure for disaster mitigation. Along with my colleagues, we kind of grouped these challenges that we thought are having more elements in common in order to have this brainstorming exercise during a workshop. Some information regarding these research challenges. So for sustainable disease management, the objectives were developing new sustainable approaches in order to detect, prevent, and manage diseases in human, animals, and plants, and also integrate medical, technological, ecological, and social factors in order to build resilient and future-ready health systems. And here, key areas to explore were early detection tools for better disease management, cultural behavior insights for prevention and care, brain health and resilience for healthy aging, smart, sustainable, and climate resilience healthcare system. And in terms of expected outcomes are portable diagnostic tools and biosensors, community-based programs to improve health awareness and behavior, and also evidence-based frameworks for brain health and healthy aging. Welcome. Just remain on the first rows. Okay. And the second challenge is ensuring healthy food and soil. And here, objectives are reducing land degradation and soil pollution, increasing soil carbon and reuse urban soils, improve soil health and structure, and lower Europe's global soil footprint. Key areas to explore are clean up chemicals and plastics, store more carbon in soils, study soil life and plant microbe links, recycle nutrients from waste. And in terms of expected outcome, here we talk about lower emissions and healthier soils, less chemical in farming, better soil functions in biodiversity, stronger and more resilient land. Is there anything you would like to add to maybe share with the rest regarding the things that I just shared with you so far? No. Good. Everything clear. So the first live activity is like getting to know each other and having the chance to move around a little bit. What we thought would be nice to have is just pick colored card from the table and form groups, but we are few, so I don't think we need to form smaller groups. But I invite you to get to know each other a little bit, introduce yourself, the university you are coming from, and something about your expertise, because we will use that later in the brainstorm exercise. So please just move a little bit around the room and talk with each other. And grab a colored paper, and also please help me with the attendance sheet with your name, email address, and signature. The colors should have helped us to form groups in order for you to get to know each other, and yeah. So I see Joseph is just writing on the post-it, which is great. I will put a flip chart there, and maybe we can stick all the post-its, and you'll receive it afterwards in order to know each other a little bit and see areas of expertise, your name, for this workshop. So, warm markers. Are here. Hope it works. Yeah, please help me with the attendance sheet. You know how projects go with this.
You have to book with the same color actions.
I think we are not so many.
Yeah, I think we can skip the grouping with colors. So, yeah. We were preparing for more than 60 people, so we are happy that we have you. You can use it just to introduce yourself, and then we will stick it. We'll stick it there. join a discussion already started. each other, finding out things that you might have in common, or discovering new perspectives. What are we going to do next is introduce those 3 topics that we selected for this workshop. I will go only on the main information or highlight some information regarding these topics, because I prepared an extensive summary regarding topics afterwards, which we'll be using during the brainstorming exercise. So the first topic selected is boosting agro biodiversity for food security and sustainable competitiveness. Here, key features for this type of call is it is a research and innovation action. Total funding for this call is 6 million euro, and there will be funded only 2 projects. Opening date was in April 2026, and it will be closing in September 2026. For this call, it is essential to demonstrate the role in enhancing food production, increasing farmers' income, and safeguarding livelihood against environmental challenges. And proposals should quantify the contribution of agrobiodiversity, develop solutions and strategies, test how instruments for mobilizing private finance could enhance the competitiveness, build on develop a decision support tool, define and evaluate the cost of farm diversification, also explore pathways for the valorization of products. Like all the calls, there are certain expected outcomes, and the proposal should contribute to all of the followings. So the proposal should contribute to gaining access to practical knowledge of clear demonstration of benefits and trade-off. Farmers, land managers, foresters are incentivized and rewarded for implementing practices that improve agrobiodiversity. Also, another outcome should be enhanced capabilities for farmers to store, process, and market their diverse raw materials and products. Another thing to take into consideration is expected impact that the proposal should reach. And this impact is given by the destination, the direction for this call. And here we can mention a more resilient and sustainable agricultural system, improved food security, higher competitiveness of European agriculture, increased farmers' income and economic viability, enhanced ecosystem health and biodiversity, reduced vulnerability to climate change, pests and diseases, and a stronger integration of biodiversity into agricultural practices and policies. What you should take into consideration are also an international cooperation, and here is strongly encouraged this type of approach, including also cooperation with China, adopt a multi-actor approach, engaging diverse stakeholders, and also the technology readiness level should be under 4. What is 4 above 4 will not be the scope of this topic. The next topic that was selected and voted for this workshop is integrating remote sensing and in-situ observation of biodiversity towards a fully interoperable observation and data framework. Here, the key features for this call are: it is a research and innovation action. The total funding for this call is 5 million euros, and also there will be funded only 2 projects, each having a budget around 2.5 million euros. The opening date will be in April 2027, and the deadline will be in September next year. Here, the scope for this topic is, in order to meet the biodiversity goals of the EU biodiversity strategy for 2030, there is a need for long-term integrated biodiversity monitoring supported by FAIR data. FAIR meaning findable, accessible, interoperable, and reusable data. Here, the proposal should address developing and validating multisensory biodiversity data integration systems, build technical capabilities for terrestrial, freshwater, and marine ecosystem, demonstrate and verify solutions in priority ecosystem and habitats, also deliver FAIR data, and contribute to common standards, metadata, data quality, and harmonize protocols. Like all the topics, there is also expected outcome, and the proposal should contribute to all of the outcomes. To advancing robust policy relevant ecosystem assessment, nature protection and restoration planning activities, strengthen capacity of researchers, practitioners, and decision makers to improve biodiversity monitoring practices and address knowledge gaps, and also enhance usability into datasets as training and validation resources. In terms of expected income, proposals for this topic should set out a credible pathway in order to demonstrate its contribution to putting biodiversity on a path to recovery and protecting and restoring ecosystem and their services. And more specifically, to one or more of the following expected impacts: innovative solutions available and applied, improve understanding of the biodiversity crisis, better informed policymakers, stakeholders, and society, support for biodiversity-friendly management practices, progress towards international biodiversity commitments, and enhanced knowledge of biodiversity status, trends, and drivers of biodiversity loss. And the third topic that we selected for the workshop is innovative healthcare interventions for non-communicable diseases. Here, key features are: this topic is research and innovation action type. Its total funding for this topic is 63.8 million euros, and there will be funded 8 projects, each project with a budget around 7-8 million euros. The call will be opening in February next year. It's a 2-stage topic. So first stage will have deadline in April 2027, and the second stage, if the proposal is selected, will be having deadline in September 2027. Here, the scope of this call is these non-communicable diseases are over 80% of the disease that burden in Europe, and the leading cause of avoidable premature death. So innovative and effective healthcare intervention are required to provide treatment and disease management solutions, and ensure best quality of care for patients suffering for non-communicable diseases when prevention strategies have failed. Here, some key aspects that should be taken into consideration is the participation of startups, micro, small, and medium-sized enterprises is strongly encouraged with the aim of strengthening their scientific and technological foundations. This topic requires the effective contribution of social sciences and humanities disciplines and involvement of SSH experts. All the projects funded under this topic are encouraged to participate in networking and joint activities, and also applicants invited in the second stage should provide details of their clinical studies in the dedicated annex using the template provided by the submission system. Proposals should address all the following aspects. Perform rigorous early-stage clinical trials. These clinical trials should be supported by completed proof of concept. Both preclinical research and the draft clinical trial protocol should be completed at the time of the submission. A sound feasibility assessment take into account sex and gender differences in all relevant aspects. Use and/or develop technologies, exploit existing data, advance research by leveraging already existing and emerging state-of-the-art research infrastructures, engage all relevant stakeholders, engage with national public health authorities and regulators, and present a thorough health economic assessment of the real-world data. In terms of expected outcomes, the proposal should be contributing to all of the expected outcomes, meaning researchers, developers, and clinical practitioners have access to state-of-the-art knowledge data, technologies, tools, methods, best practices, trainings. Scientific and clinical communities can use innovative healthcare intervention. The scientific and clinical communities should make wide use of relevant databases and/or integrate them with existing infrastructures. Policymakers, scientific and clinical communities, developer, patient organization, regulators, and other relevant bodies should be informed, and patients and caregivers are constructively engaged with the research. In terms of expected impact, so the proposal should be contributing to several of the following impacts. Disease burden in the EU and worldwide is reduced through effective disease management. Premature mortality from non-communicable diseases is reduced by 1/3. Healthcare system benefit from strengthened research and innovation expertise. Citizen benefit from reduced health threat of epidemics. Patients and citizens are knowledgeable of disease threats, involved and empowered to make and shape decisions for their health. These three topics were voted by the people that manifested interest for the workshop. That's why we choose to present them and highlight important information regarding these topics. The next activity is also an interactive one. It was meant to brainstorm on these topics, and we should be forming some groups, choose a topic, and see what ideas could apply or set a direction for a future possible proposal under one of these three topics. because we're few, I have a question for you. How would you like us to organize, having in mind these three topics that are on the table? I have a description for each topic, so you will have information, not only what was on the slides. There are extensive information there. Yeah.
Since first of all registered like 70 people for this workshop, and now we have like 10 or 15.
Okay.
Maybe you can ask the audience which of the three proposals actually fits their interest the most.
Mm-hmm.
Because I could feel like that there's no match now.
Okay.
Maybe it is, so maybe you can ask that way.
Thank you. Thank you for the suggestion. So, having in mind Joseph's invitation, is any of these three topics an interest of yours? Topic 1. Mm-hmm. So,
We have a slide that shows.
yes, we will go back to the first topic. Boosting agro-biodiversity for food security and sustainable competitiveness. This one? Okay. Is everyone comfortable working on this?
Or does anybody want another one?
Thank you for your help. Yeah. Unfortunately, I didn't foresee having all the three topics together. So, is boosting agro-biodiversity for food. The second one was integrating remote sensing and in-situ observation for biodiversity towards a fully interoperable observation and data framework. And the third one was innovative healthcare intervention for non-communicable diseases.
There you can get the most money. That's what I understood.
Yes. But there are also a lot of things that you need to take into consideration before you get the chance to reach that amount. Okay, so we'll have topic 1 because there is someone interested in his second topic. Okay. So you can adjust. You can come up with a perspective from a UTCB point of view. What could be or your contribution in regards with a possible proposal. So what I suggest will be to just form 2 groups. We'll have those 2 topics dedicated to soil challenge, okay? And just pick a sheet where you can write down your ideas, your possible partners in a possible consortium, and let's see what things could come up with after brainstorming on these two topics. Is it okay with you? Cool.
Would you please be so kind to go back to the slide with the title of the topic?
I will give you some sheets with the information for the topic. If you want to go to the topic online page on tenders and the portal, just scan the QR code. Hope it works, but I'll have for you all the information you need of the topic. So who will be working on topic number 1? I have someone here. Okay, for
come so far, but what we found out, our title was Boosting Agro-Biodiversity for Food Security and Sustainable Competitiveness. And we found out that we have some experts in SCTU, Rostock, AUA, probably, and Croatia, and we want to link those researchers together to apply for this call. We also said that we might build some links to agritourism in that field. Well, that we might need some experts with IT components as well, but that's the state of the art, so we are not any further.
Thank you. Thank you for sharing, Arn, for putting ideas and energy into the brainstorm exercise, as short as it was. Okay, let's hear your ideas from your point of view.
Actually, our topic was about integrating remote sensing and in-situ observation of biodiversity toward a fully interoperable observation and data framework. Actually, it's a little bit much towards data processing than we can afford, but we're trying to make a sort of an analogy with what we were working. First of all, we need a greater team, so we need some other specialties more than civil engineers. Then, because being civil engineer means a lot, we all draw the conclusion that we need to process data using drones and in-situ sensors, and also we need to use the GIS system, which is a mapping system, and we need to collect data, because actually everything related to what's happening in fields can be collected by GIS. So, yeah, that's why my colleague says that the conclusion we reached was that we need someone to be able to solve the problem of correlating data. Because on the other side, we do get the information from in-situ sensors. These sensors are several types of sensors. Now, if we go into deep, we have physical sensors, we have movement sensors, we have time-dependent sensors, so we need someone to be able to correlate everything, and maybe to use a higher level of data basic systems, because we are a little bit like targeted, but this is something that we were asked for, because the question was what we were thinking about or asking for if we have such a topic. So maybe first of all we asked for a computer engineer, someone really good in databasing systems, and then we are using its skills for monitoring in this way. In addition, we will need money. This is we will need resources, partners, specializing in biodiversity. Presentation. We use that reference on specific presentations from yesterday, because we try to find the reference point to relate to, because we're not specialized in this. We can help out organize, or we can put our knowledge in terms of sensors.
And contributing to certain activities, or
We need a specialized team, more special
Yeah.
to different layers of biodiversity.
Yeah, this was just a brainstorm exercise to see if we have a certain topic in front of us, with what can we contribute in order to maybe make possible a project proposal. And even if we are not specialists on that certain topic, I'm sure that in most of the cases there is something specific that a member of the Alliance could contribute to the project, or know someone who could do it and just share the information. I have 2 more slides for you, just a few ideas in order to wrap up. So here are some tips. We encourage you to read the call text and the general introduction very carefully, because there you will find most of the necessary information when you decide to write a proposal. Start early and submit, of course, before the deadline. Use the application template, because this will guide you in order to work your project draft. And go to EU Funding and Tenders portal, and there you will find all the information you need for your possible future proposal. And if you need help, Project Development Office is here for you, so write us. Yes?
I need help, Bianca. In which of those calls was China involved?
I think their call. We can check, okay? Don't forget Funding and Tenders portal for all the opportunities, and of course you can also access national contact points if you want specific information or maybe feedback, check certain aspects of your proposals with them. Thank you. This was it for the workshop.
Okay, let's start. Good afternoon, everyone, and welcome to the final showcase of our hackathon, Gamifying Agricultural and Biotech Education. Over the last days, participating teams have worked on a challenging task to transform agricultural and biotechnology concepts into engaging digital learning experiences for students of 15 years old, making scientific knowledge more accessible, engaging, and impactful. Today, we will have the opportunity to see the results of their creativity, their teamwork, their collaboration, and their scientific understanding. So all participants, all participating teams will have 5 minutes to present their project to the jury and then explain to the jury the educational challenge the specific project tries to solve. And then, after each presentation, the jury will have 2 minutes in case they have any questions. Okay? I would like to thank all the participating teams and, of course, the students that came from SCTU to join our hackathon. And, of course, I would like to thank the jury members, the mentors, and all collaborators that contributed to make this event possible. And now, with no further delays, let's start with the participations and discover the innovative ideas our teams have developed. So, the first, okay, Manos. Έχεις ήχο,
So, hello. Oh, I'm too close to the microphone. Hello, everybody. I'm Manos.
Sorry, Manos.
I'm a PhD student
I'm counting your 5 minutes.
Okay, let me change the desktop because here I'm presenting on the second one. What? Come on. Okay. Wow. For some reason, I cannot see it on my computer as well, which will make it a little bit difficult for me. I will just be looking there. And let's start. Oh, there is even worse. Okay, hello everybody, I'm Manos. I'm a PhD student in the Agricultural University of Athens, working in the Environmental Laboratory, Environmental Biotechnology Lab. This, well, I'm part of a team, but my team member could not attend because she's sick. We were 2 people. I'm here presenting alone. We designed this simulation application, the Rhizosphere Defense, as you can see, because we thought of something very simple. We tried to make like a little time travel back in the days when we were students. I invite all of you to do the same. What happened when you had like some boring lessons or something that did not make sense then, or you didn't like it? You didn't study it. So we decided to try to make a fun simulation about something that's very difficult and complex for a young student to understand, which is the rhizosphere and the complex interactions there, and how can climate change and elevation of temperature and salinity and other biotic and abiotic stresses can affect our plants, and our plants eventually will lose their ability to live. They will die. So, we decided to make it like this. This is a simulation where you either have, the teacher has 2 options, either to start a 5-year campaign where the levels get progressively more difficult for the plant to survive and the students have to implement their biosolutions in order to help their plants alleviate the stress, which forces them, actually, to understand what each thing is doing This application embraces a digital twin mindset, so we take real data from various soil conditions and some pathogens, and we have real, let's say, helpers, a little bit simplified because we still remember that it's 15-year-old students, so we just selected some bacteria and some fungi that will help the plant survive. It's a 45-second run, and it's in 5 stages, so it's quite fast. And afterwards, it gives you some insight on what you did wrong, what you can do better. And also, let me just pretend that I'm running something. I'm selecting 2 beneficial microbes. And here I have the option to select either the chemical fertilizer or a biofertilizer. You have some biocoins. I'm very sorry, but I did not expect to have this good of analysis on the screen, so everything seems small. In my computer screen, it's better. Sorry? And here you can see that the simulation is running. We had the random event that the humidity increased, and there are some Phytophthora fungi that will kill our plant. And unfortunately, because I in purpose selected wrong bioinoculants, a wrong strategy, our plant died. Here you can see why it died. I unfortunately cannot find my cursor. Sorry about this. I promise that it's running, but my cursor is not there. So, okay, here, okay, whatever, let's continue without the presentation. Here I just showed that the student selected the wrong set of microbes and didn't use his options. There is a message that says what you can do better, what can you implement to save your plant, and also there is the option for the teacher here to explain and make the students understand why it didn't fail, what they can do to make better. Apart from this, there is a second option, which is the free play sandbox, that actually might have a broader reach. If I could use my cursor, I would show you. There you can stimulate all the bio information of the soil, humidity, pH, salinity, and implement exactly your field, what you have on your field. And if you're a farmer or someone that is working with land or a company, you can try various combinations of bioinoculants and decide what you can put your actual money and research what might be better for your personalized field and your soil health there. All in all, how much time do we have? Okay. Yep. So I had some failures with the cursor, but yeah, I'm open to questions. Thank you.
Any questions from the jury?
What is the presentation? I decided that it's better to show you the live application than have a presentation with slides. I think it's more fun.
Okay.
Well, first of all, we see a rising tendency for the 15 years old that they cannot keep their attention because of various multimedia, dopamine-related stuff that it's bombarding them. So we are trying to make a fun and interactive way for them to understand a complex network. So I believe that even for me now, being like nearly 30 years old, it's very difficult to just read from a book. I prefer to have something more interactive, and I think that the 15 years old need this even more. We see rising ADHD levels everywhere, And it's a way to capture their attention, make them think, and strategize accordingly to solve a specific problem. So I believe that it both helps them with learning about the rhizosphere, and also helps them to form a valuable strategy how to tackle a problem using the tools they have. And also there's a small transaction system implemented in the game so they can keep their extra funds, because they have some eco coins, and you can store them and recreate them. So it's like a broader educational thing. Sorry? Well, if I press X in this box, I can repeat based both on the comment that the application gives, also with the guidance of the teacher. So, and the teacher can be part of the game and explain what they can do better. So it's not that we exclude the teacher, he's here to help and give some positive or guidance for them. Any more questions?
So, I get it. So, this has a intuitive, you can learn, you can play around, but the defense, the word defense puzzles me when it comes to interplay, molecular understanding of the microcosmos and what happens over there. Evolution doesn't work with defenses.
Yes.
Okay, so how do you think that this can... I think that this is brilliant, honestly. Honestly, I admire the quantum approach to a non-linear system that you try to bring here, because you break it down into manageable portions that we can eat and understand and consume. I get that. But in a real life scenario, you don't defend against anything. This is an ongoing process. You understand what I'm saying?
Yes, okay. Yes, totally.
So how would you see that developing? So if we are here to give you $1 trillion in funding, how would you not use that money to a non-defensive scenario? A linear, ongoing thing that we understand. You know that you're not defending against anything. This has been going on for 4 billion years, okay?
Yes.
So how would you see that developing in the future?
Well, for starters, this is, like I explained before, a trial to bring a digital twinning thing. So with enough funding, I think that lots of monitoring and data absorption and machine learning models would be implemented there. And you could have like thousands and millions and billions of strains, bacterial strains, and their molecular... You told about infinite money, right?
No, I'm actually,
Nearly infinite. Lots of understanding of communities, lots of real bioinformatic in-depth study to implement this data and this correlation about the communities and how they interact in the rhizosphere. At the same time, monitoring its physiochemical condition of the soil and every possible molecular pathway that takes place in this interaction. If you can build a model to hold all this information together and connect the nodes and everything, it would be like a real-life simulation that everybody could even predict the future of their field. Yeah.
No, I buy it. It's wonderful. And you know, ancient Greece was like this. Athens was fighting thieves and Sparta and everything, but then Persians came and the community became one. So I think that what you do here is wonderful. But it depends on the level of the resolution. How deep you want to go in the wormhole. And I think that this is something that is scalable, and you can use it from, I don't know, primary school to super professor level. I think it's very well done. Congratulations.
Okay.
Thank you.
Thank you both. And now we can move to the next theme, please. Okay, now we're ready. Your time starts.
Yes. Okay. Yes. Genetics and crop management. For most 15 years old, these two words are just really complex and boring. And my name is Mikhailo. That's my teammate Nazari and my teammate Marwan. And I'm proud to say that AgriBloom fixes both. We make the complex clear and the boring addictive. AgriBloom is a game where students grow virtual plants, and the only way to make them grow is to learn the science behind it.
Oh, sorry. And the topic we teach are DNA, CRISPR, photosynthesis, hydroponics, and plant breeding. Every lesson is grounded in agriculture and biotech, accurate for class, friendly, and understandable for anyone. And specifically for our targeted 15-year-old audience, everything fits in 30-minute class. Short challenges, simple language, clear feedback, no long theory, and yes, that's the video. No long theory. A teacher introduces a topic, students play through it, and there is still time to talk about what they learned.
And about the teachers, we emphasize their important role in our project by making sure their environment is easy and clear to use. As you can see on the screen, a teacher can create a class in seconds and share a joint code to students. Teachers are able to make announcements that go straight to students' devices, and even see live analytics that shows which student is falling behind or even ahead of the classroom. Also, teachers can make quizzes that they can. Also, teachers can make their own quizzes, custom quizzes, or even choose from our 30 prepared pre-made quizzes that we have in the current unit system. These units have several unique and interesting formats, such as crosswords, debates, or even challenging boss battles that reward you with XP achievements, cosmetics, and even gems. Another gamified system aspect of our project was the growing your own plants. Think of it as your own personal Tamagotchi, you know? You can take care of your plants by balancing water, sun, nutrients, and protecting them from pests, weather conditions, and secret events. But what's important is that you can genetically modify them using practical knowledge the students learned from our units.
Yes, and everything we described is a real working web app. Live right now, real accounts, 30 units with several different question formats, the full classroom suite, daily and weekly quests, achievements, topic mastery, and even profile customizations, just for fun. All built and all running. Also, two things that are important to mention. First, accessibility. It's easily accessed from any device just using one link in seconds, which gives an ability to start the education immediately. And the second one is security. What is important that we are all three cybersecurity students, so we can assure you that our platform is fully protected and secure. When your users are kids in a classroom, keeping their data saved is not optional, it's foundation.
Yes, I totally agree with my colleague, and that's why all our data is stored in Supabase and passwords and hash. We use Vercel for hosting for 24/7 access, and Brevo for fast responding verification emails.
So we started with two words, if you remember. They sounded really complex and boring, but we hope in the past few minutes we've shown you that they don't have to be like that. And with AgriBloom, a 15 years old can grow a plant, engineer its DNA, and leave the class knowing the topic, the DNA. And yes, hopefully we made complex clear and boring addictive. But as a cherry on top, you don't have to take our word for it, because we prepared a QR code and anybody can access it right now using a scan or go into agribloom.garden. Thank you.
Thank you. And
yeah, we
just
already...
One question from the jury.
Would it work for an older cohort of students, maybe at university level or indeed at primary school level? Have you thought about that?
Oh yes, because we really like what we made, and we think of we can easily expand it further for both, I know, higher, like third level education, so in universities, or we can still stay in like secondary school and not just be based on agriculture. We can also expand subjects like biology, chemistry, and physics, like we stay in science. But even now, it's made for any age, really, because since we were working our additional constraints, which were 15-year-olds, that's where we focused on a presentation. But even now, it is like playable for a person of any age. It could be older, younger. Like the Tamagotchi reference is, I think like people do get it, like of any age they do understand, or at least some people remember what a Tamagotchi is. So yeah, that is definitely expandable and playable friendly. Huh?
Oh, it's an old toy from the 90s. It's like a little keychain, and you grow your own pet. You feed it water, you clean it, you take care about it. Yeah.
Okay, thank you. We move to the next theme, please. Okay, your time is counting.
Okay. Good evening, my name is Tassos, I will be the presenter of the team. This is my colleagues Ilias and Evelina, and we created a game called Synthorythm. Synthorythm is a game, this shouldn't happen. Synthorythm is a game about synthetic biology. Synthetic biology isn't magic. It's about taking control of nature's microscopic manufacturing plant, and instead of using steel gears and wires, we use living materials and DNA molecules to build the ultimate biological gadget. Why it matters? Flips passive memorization into active problem solving, turning students into biological engineers who build real solutions. The students will not even realize they are learning, because let's be real, it's not about failing or passing a class, it's about learning. This is the start page of the game. So where's the pointer? Okay, so this is the start page of the game. As you can see, here the players can go into the sandbox and play alone, or go into the classroom mode, and the educator will provide the classroom code, they write their name, and we have a dashboard for the educator to see their progress and the results. After the game, the results can be reviewed by the teacher and discussed accordingly. Also, I would like you to note this comment, that this game is designed to be played alongside the wiki, and we invite the students to have our wiki open. I will tell you more about the wiki in a minute. How do you play? You enter the game, this is the start page, and you either choose to fill your credentials and connect into the classroom. Here you can see the level and the name of the level, the description, your score for the past levels, that you're connected to the dashboard, and your credits for the game, and the level targets. Here you can make your choices on what you're building, how it works, what promoters and everything. And here you get your score. Your score is important because this is according to how real synthetic biology is evaluated. So if the student accomplishes the target, they get this message. If they don't accomplish the targets, they get a fail message to do the level again. They don't get out of the game. So, our wiki. We thought about having a wiki because we want the students to be able to do their own research. In real research, in our universities, we did the research for our thesis. We had to look for things. We had to know where to find things. And this is something that our schools didn't teach us. So in this game, the students have the wiki where they can find everything, but they have to look. Sorry. Okay, this is from the wiki. This is mission 1. The wiki is, here the wiki you can see they have the intro and its mission out of 8. This is mission 1. What is mission 1? The neon signs of District 7 are flickering, but that's not the only thing glowing tonight. A corrupt megacorporation just dumped tons of liquid arsenic into the municipal reservoir. The underground activist group has tabbed the user for their first real-world deployment. What are they going to do? And also this is Alex. Alex Helix Vane, it's the virtual assistant of the game. They are an underground biohacker and Synthorym recruit. We want to talk about some bigger things of this game. Forget boring memorization. Kids actually research and connect genetic engineering to huge global issues in this game, like microplastics or brain tumors. It's a total sandbox. Instead of linear tests and memorizing things, students get to mix and match parts to build their own custom genetic circuits. Players stay hooked because they have to make tough, tactical trade-offs, like risking key features to stay under budget. We use simple analogies, like calling a promoter an input switch, so 15-year-olds get it right away, and the whole 8-level game fits neatly into a 30-minute class session. The backend runs on a robust Flask framework that safely catches missing inputs, so the game never crashes or slows down during the play. And we also want to talk about our future perspectives. Our game is adaptable to other audiences. It's really easy to do it. You just have to change the wording in the wiki. The commercialization of this is really easy. It can be introduced in school programs. We want to scale the content in the next few weeks, and we make it to be compatible with learning management softwares. We want you to have the time to test it on your own. So here you can see our game, and here you can see the wiki. Those are links for live deploy of our things. Thank you very much.
Thank you too, guys. And any questions from the jury?
I can see that it's already really, you have proceeded very well. Regarding the LMS compatibility, can you tell us a little bit more things?
Of course. First of all, I couldn't tell that in the presentation for time management, but I have to inform you that our code is public available. It's on GitHub. You can see we're into code, open source things, so we posted our code in GitHub. So what you will see in GitHub, you will not see the modules for the compatibility for a Google School or a Moodle, but we have ready to be deployed scripts that this game can be connected with Moodle or a Google School.
What other scenarios are you exploring?
I'm sorry, Professor?
What other scenarios are you exploring?
Okay, you mean scenarios in the game or scenarios about what we will do with that? For other audiences. Okay, first of all, synthetic biology is a very complex issue, even for us. We're biotechnology students, senior year, and it's a very complex issue even for us. So the easy audience, I can tell you, is university students or college students. The next audiences we would adapt to is industry trainees, like a corporation wants to test industry trainees' knowledge, and they can use a version of the game, not the game as it is, because it's adapted to 15-year-olds, but it can be easily adapted to, let's say, industry trainees. Thank you very much.
Thank you.
Right. One more thing.
Sure.
What about those two guys?
For time management issues?
For time management, please say something.
Of course.
Tell me.
Otherwise, for time management, you should have sat down. But say something about why are you there? Why are you standing there?
Sorry. First of all, it was for time management. Secondly, it was because of anxiety. But sure, you can ask anything you want.
No, say something about a couple of seconds.
Okay, so the main idea was to just unravel the difficulties of biology into 15-year-olds, which is not an easy task. I knew from a very young age that I wanted to become a biologist, but to be honest, it was neat information and not exactly a nice way, an educational way of teaching in school. So yeah, we made this game in order for teachers to just help students learn biology, synthetic biology, and as you can see, we have scenarios not only for agriculture but also for biomedicine and many others.
And you?
Where we were in school, we learned just to read and memorize things. Then we went to university and they told us to do research. And for us, it was very difficult because we never learned how to research, how to evaluate things, how to know what is wrong, what is correct, what is more suitable for each scenario. So with this game, students that want to be scientists and study biology, they will learn how to search things and how to solve real problem scenarios. That's all.
Thank you.
Perfect, thank you.
Do you want to ask something else?
No. Thanks.
You can ask if you want.
We can move to the next theme.
Thank you for your attention.
So, this presentation is all about accessible and engaging biotechnology education, and it's focused on the secondary education because of the theme. The main problems that exist are that schools have limited funding to get materials and lab equipment, and they also need dedicated space for it. And there's need for, and because schools are understaffed sometimes, there is also need for Sorry about that. I'll go on. Another thing is that
Relax.
Yeah,
take your time.
Just explain what you know, your ideas. Yeah, just explain it.
The current learning approaches are not working as well as they could because of how they are right now. And so I firstly identified some ways that they could be improved. And after that, I came up with a solution for the problem of from the limitations that exist that lead to education not being equally accessible to every student and not easy to comprehend. That solution is called Biotech Virtual Laboratory, or BVL for short. And it aims to, it is an educational web application and that is accessible from any device for accessibility reasons. And it has and it connects, it aims to educate students while having them solve challenges that are connected to real-world problems. These are some concept images of the experience. And the concept is that a teenager would engage in this kind of educational activity because by nature teenagers are curious and active learning is a powerful tool to teach anything. So by having them experience closely, by having them have an experience, a direct experience, even a virtual one in the science domain, they get to learn way more stuff than they could when they maybe happen to have an experiment showcased to them, but not actively participate in thinking about it, connected to real-world problems and for the stakes, and learn themselves and get to explore and research and find out how things could lead. There are some gamification features, and for the sake of time, I would like to point out a few, just a few. The fact that they would be able to get trained on the fact that they could get trained on how the lab has safety procedures and how to use the equipment. They could cooperate in teams to build communication and teamwork skills or compete against other classmates. There are some achievements and budgets involved. And they could see directly how science can impact the inward space and community, but that also reflects the real life, and it teaches how science Science is needed in... sorry, I cannot explain that well. I have some examples of how the plan is for an educational plan to work. And an example of this I would like to stress out is that they could, one challenge provided is that microplastics could be found in water supply. Then they would learn, because they want to fix that problem and because it's serious, how to actually use technology and biotechnology to tackle this issue. They would get to research using the simulations and curated virtual lab experience to how to propose solutions like, for example, test bacteria strains that and how well they could dissolve the microplastics, and finally see how they would self-assess basically how the impact was, and that leads to reflects more on the real scientific cycle, because they will not just be told that they did it and it's complete. They have to find ways to improve upon it or see what went wrong. And that is an educational advancement, because as papers showcase, there is a real problem in many countries where the scientific literacy level is very low, and that creates many problems. So this solution aims to facilitate with the situation. The expected impact is for teenagers to get to have a better and more engaging experience while collaborating with teams and even being pushed into more STEAM paths. For schools to save up on funding and to provide more equal opportunities for their students.
Please sum up.
And for society to have more scientific literate people, which would improve democracy, and even more, they would be able to create informed decisions and think for themselves, which is critical for society.
Okay, thank you. And now, maybe the jury has a question.
First of all, you need to relax. Okay, we're not here to decapitate you or relax. We're here to communicate. You have done some wonderful stuff. You should be proud. We are proud of you. You should be proud of yourself. So take this opportunity to understand that you don't need to give any kind of performance to anyone. Relax, enjoy it, be yourself. And how do you reward? How do you decide how to reward? Because you work on a reputation system. You give a penalty or a credit, a bonus, depending on the performance of when you go about your game. Okay? How do you decide how to penalize or give some credit to someone? What is your reward system within the game that is actually linked to real life and biology?
That's a good question, thank you.
Welcome, but relax. Say it on your own terms. You don't have to follow any rules. Relax. Don't relax.
Okay, the plan is not to penalize students for wrong decisions or not so great ones. but to have them, the drive is their motivation is that they want to find a solution to the problem, a good one, a viable one, one that could work. The reward is that they get to solve the problem. There could be other features added, like customization or better equipment for advancing in the experience. But I think it's more important to have them my point is that I want to go beyond gamification, to have them motivated to learn out of curiosity how they can fix the world and actively shape a better future, rather than having them win some things in the game, to get educated more.
What's your first name? Nikos. Nico. What do you gain from that? Do you learn from that feedback? Do you get feedback from that and you improve your game? When they reply, when you get the feedback?
At the end of the cycle?
Yes.
Okay.
Do you improve your game? Do you learn from that? Do you get feedback from the user?
Feedback would be, okay, feedback comes in form of results. For example, how decontaminated was the water, or how many people could get infected with plastic pollution in their bodies, and they would get to decide if they could actually improve the solution. The thing is that they have to get to think from themselves, to have critical thinking about whether the solution they provided was the right one for the problem, rather than having them being told what to do exactly, because in real life situation we are not told how to do research or how exactly we could find a solution. We get to have critical thinking and explore how to get there.
Okay, Nikos, we have one more question.
Nicholas, myself and Sophie have the same question. We just want to know more about the actual game, but can you say it in about 2 sentences, very short? How does the game work?
The game teaches basic
I am a student. What do? I start. Press play.
You learn how the lab works, the equipment. Sorry, I try to translate, so I will say it like that. After that, you are presented with a challenge, with a set of challenges. So you choose which one to go on with. But you can, as you learn and progress in the lab and unlock more skills, you can also tackle again the same challenge to have better results. And
that'll do, Nicholas. Okay. Yeah, we got the idea. Yeah, that's fine. Thanks.
We move to the next theme, please. Thank you, Nikos. Okay, let's go.
So, let's imagine and pretend, for example, we have a bottle in our hand, and you're thinking, where do I have to throw it? In a blue rubbish can, yellow rubbish can, or in a general waste? In here, we give you the solution for a similar problem, which is called ECOScan, an app that will help you with it. And basically giving you, like, making every object that you have your lesson. So, the problems in the world. So basically, it's very connected to agriculture and biotech. As for example, like lots of batteries. Batteries are usually thrown away or in the general waste. All the heavy metals like mercury, cadmium, they all go into soil, breaking apart all the molecules of the soil and making it not good for agriculture, making everything bad. So this is what we have to do. Try to recycle anything or maybe upcycle.
The core feature of EcoScan is the scanner powered by Google Vision AI. So the idea is simple. You scan any object, a bottle, a can, a newspaper, and it gets a result is in 2 seconds. The AI identifies one of 15 waste categories and gives you a tip how to recycle it or where to reuse it. You also earn eco points for the scan, which display you in the leaderboard. And if a student scans what their teacher assigned, that lesson is completed automatically. So, in this video, I scanned 3 objects. It's a phone, it's a bottle, and toilet paper. There we have 2 options. Recycling options, which tells us how to recycle and where to recycle it. And upcycling, which suggests us how to treat the objects.
So yeah, we have a lot of features. So the map, it shows you the points where you can recycle whatever you want, and it shows exactly each point and what it's accepts to recycle. In activities, you have quizzes and a guide where you can learn what exactly you should recycle and how. And we have an interactive planet. It's like a Tamagotchi, and it shows the user's environmental impact in a visual way. And by recycling correct and completing activities like quizzes, as I say, user can improve this planet and see how their actions help the environment, and like how much water was protected or how much CO2 was saved. And we have a profile where we can show the user's level, scan history, how much he scanned and recycled, and that motivates user to proceed and recycle more.
Why EcoScan works? So basically there is no age barrier and there is no very low limit. So basically it just, you open the app and immediately the camera opens up and you tap once and the scan is completely there, instant result. And the real gamification here. So basically you get experience for scanning recyclable things. And by that, you also impact tracking your CO2 and water saved. So, like we saw on the planet, so we can every time we scan, the planet becomes greener and greener. And there are teacher tools. So basically, a teacher can give a lesson for a student, and student is able to complete them. So who is it for? As I mentioned before, we can use it, we can give it for students. So basically, students can get a lesson by their teacher by creating like a topic, describe the lesson, and give the target to scan. And the teacher can give any amount of points for the level. When the student scans anything, he gets the points by the app and also extra points that the teacher assigned to the student. Teachers can literally, it can help teachers to teach their students with guidelines and also with any results, basically. And eco users, so any person can actually use it and also help the planet with that and agriculture, everything. Scan, Know, Act. So this is basically about our app. So when you scan, you get the guidelines, what to do, and act. You then decide what to do with it, recycle or upcycle. So nobody just learns, people actually do it also. So basically put in the knowledge. Thank you.
Any questions from the jury?
Well done, lads. Sorry. Getting too excited, sorry. Just in terms of the challenge you were given, so we're looking at a 15-year-old secondary school student. Do you think they'll be engaged with this, or how have you thought that through in terms of encouraging them to go back and continue to use your app?
It could be just because in my own experience, many students really like competitions, and I think agriculture students could actually get any lessons by the teacher and actually study by that. So I think it would fit really well for a 15-year student and even younger or even older.
Okay.
Right, two things. First of all, there are 4 names there and you are 3. Who is missing?
So basically, that had to be our team leader, but he couldn't come here just because he's under age of 18. So basically, he would have to get some insurance.
There was something that I wish I put all my money, my soul on this. Under 30 seconds, as a teacher, you create a lecture.
Sorry?
In one of your slides, you said that the teachers can create a lecture in. Create a lesson, sorry, in 30 seconds. Please.
So explain how to create the lesson, or what?
Yes.
So basically, you can see on the screenshot in the middle, it's not really visible. So the first is topic. So teacher writes down the topic. And then description. So teacher can give any description, like what to do, maybe even give a little bit of text just to learn what to do. And the third one is your target. So the teacher gives the target. And you can see the XP and echo points, which goes to the leaderboard after that and makes people compete, which you can see on the third screenshot. So there's a leaderboard.
But there is an algorithm that is deciding.
It works now. Yeah.
Which is a random forest thing. How do you decide which parts, which bits you put together to create a lesson? What is the algorithm that runs behind the application that will guide you to create a lesson? I cannot create a lesson in 30 seconds. Even in 30 minutes, in 30 hours. How do you decide how to create a lesson?
So now you can only, so the teacher can now type the exact item that you need to scan to recycle. And when you scan the lessons, if you scan the right object, the lesson is complete. But maybe in the future, to really create fast lessons, we can adapt AI. So you just type a short description, and based on that, I can create an actual lesson.
I see, okay.
Okay, thank you. Thank you. We move forward to the next team. Technical issues.
Άντε, κυρία Λέκα, τελειώνετε.
Good. Okay. We can start.
Hi. Okay, so I'm Rito, representing the plant play produce team from the Agricultural University of Athens. Okay, so imagine that you're a teenager and that I ask you to name 3 species of bees, or maybe what green biotechnology does. So most people link bees only to pollination and biotechnology to sterile lab work, which is pretty much, pretty much far from the truth. Now imagine taking this shallow understanding and turning it into a game that plays like Super Mario Bros, but instead of, do you mind? Thank you. But instead of jumping onto, turtles, you use biotechnology to save some of the world's most treasured pollinators, bees. All right, so we're tackling twofold problem. Most teens view agriculture career options, as outdated, while traditional classrooms fail to show how biotechnology applies in agriculture. So here we come with our Epikinesis project, which is an arcade-like platformer specially designed, for 15-year-olds. So Flora, the girl you see over there, is a young researcher who has engineered a cure for a real-life bee pathogen that causes European foul brood. She travels around the globe to deliver her life-saving therapy to diseased hives. In our game, the enemies aren't villains, but zombies. Do you get it? Zombies. Come on, people. Have some humor. All right. Which are bees infected by the pathogen. So Flora does not attack them. She actually very empathetically avoids them, trying to promote the One Health perspective to the users. Every time she clears a level, a page unlocks in her notebook, which doubles with a teacher's manual, containing open-ended questions on bioethics, biosafety, sustainability, ecology, and actually contains chapters on bee biology, bee anatomy, the ethology. I mean, do you know that bees dance to communicate? Yeah, you do because you're an agriculturist, but anyway, 15-year-olds don't. So at the sensitive age of 15, students contemplate on their career choice, and our game navigates them through that procedure. What makes Epikinesis unique is that it's it's 100% handmade vintage designed in arcade style by Maria over there, rejecting modern overwhelming graphics. So it's user-friendly for students with educational challenges like ADD, ADHD, dyslexia, and it also contains features that help students with and individuals with sight challenges. You can change the contrast, you can make the fonts larger, etc. What's also very cool on Epikinesis, sorry for doing that in the microphone for my voice, but okay. What's very cool, in my opinion, is that it contains a real-time API weather app. It links to live data and it imports it into the game so that it's actually updated to the weather of the geographical position of the level that Flora is attending. But you'll see it in a minute. And also we have Glenn. He's an AI scripted assistant, and he actually he talks if you want to. He's a speech to text helper. So without further ado, this has no sound. Oh. Okay, so it's not just a silent thread, it's a silent video. But this is Flora, and it's like Super Mario, but it's more biological. It's more biological. It's a shame you cannot hear the music. what is more is that you can actually change some features in case you don't want the music, you can turn it off. It has sound effects, you can turn them off and on as well. And this is the template, this is like the globe, and you start from Athens and you go to Uganda or Tanzania or the Himalayas, you end up in New Zealand. And along the way you learn about cool stuff. You learn about the bees and why they're so important. But you know, it's not just the pollination. It's mostly a matter of ethics and of respect. Because all organisms have their own peculiarities and quirks. Bees are no exception to that.
To mention that Glenn, the beekeeper, one of his purposes is to make the game a little bit more accessible. That's why you can change the contrast and you can make him read the text and ask him questions while in game or on the lobby. So if you have stuck on at some point, you will be able to readjust and keep playing. And also, the manual is accessible to both to the teacher and the students, so they can have a Q&A during the classroom. So we expect about 15 minutes of actual gameplay for the students on a room with computers. This just runs through a link, you click on it and you play it, as you'll see right now. And also 15 minutes where they discuss about key facts about the bees and how the environment and everything makes the bees to live.
Okay, thank you.
Thank you so much. So play like it's 1986 and learn like it's 2036 and protect the pollinators. We have not put our names on the presentation, but thank you. And, and that's the QR code you can scan in case you want to. Yeah, thank you.
Any questions from our jury?
So, if I'm a kid and I'm running through the Super Mario thing, because that's what I'm thinking of, right? Can I skip all the facts?
Yeah, sure. I'm sorry, I didn't hear it.
Oh. So if I'm running through the game, getting through the level, you know, jumping up and down and all that, can I skip all the facts? No, skip.
Yeah, you can double click with a space bar and skip them and move on. But okay, this is not encouraged.
No, that's what I wanted to hear, that I don't want the student to skip the facts.
It's mostly, okay, let's say that student actually misses a fact by accident. Glenn, the AI assistant, can tell him what he just missed. So the NPCs, while in-game, I can show it as well. In case you miss it, he can repeat it to you. But in case that the student is bored and doesn't want to, it's something that it's irrelevant to him, okay, yeah, he can just skip it.
But I guess that you're not going to play something if it's boring to you and has like no value to you. In my
Yeah, but I'm just thinking of it as a classroom, you know.
As well,
technique.
there is a notebook that collects all the facts and from the NPCs and extra information, so he can come back to it and, yeah, like level 1, for instance, here are some dialogues and some key facts.
Thank you.
As an example.
Thank you.
Yeah.
We have another question, I see.
Who's Glenn?
Glenn is the guy. I'm sorry.
Glenn.
Wait.
The AI assistant.
Yeah, of course, but is it a male bee or a female bee?
I'm sorry?
Who's Glenn?
He's Flora's best friend. He's an assistant. He's a beekeeper. He's a...
Yeah, but...
He's a helper, yes?
Yeah, but...
I don't understand the question. I'm sorry.
To be or not to be? Exactly. But he's giving you some... You are interacting with Glenn, okay?
Not necessarily.
Okay. So why
you're interacting while in game? You're interacting with NPC bees that have a specific species in that area. For instance, you're at Himalaya. There is a certain kind of bees there,
Okay.
and in that case, you just interact with them. But if you have a question, you can ask Glenn. Or while in lobby, you can also do that as well. So Glenn is just a support to what you do. It's like a specialist. He's a beekeeper, so he knows stuff about bees. So in case you have questions and need extra support, you can rely on him.
So he's an AI assistant?
Yeah, pretty much. Yeah.
Okay.
Okay, now we thank you. And we can move to the next thing. Okay. The last theme now.
And now we're back.
Okay, you can start.
Good evening, everyone. We are software developer students from Southeast Technological University in Ireland, and today we would like to introduce you our new game called PlantX. PlantX, it's an app that helps users to learn about plants and nature. We noticed that learning about plants often feels boring, so the question became, how can we use games to make learning about plants and food more fun and easy? For many of us, plants is just names in the book, not something we actually see or touch. Outdoor lessons for students are also difficult to organize. And it can be hard for teachers to access students fairly. Our app, PlantX, scans real plants, find out their names within an app and collect them, and you can earn points during the collected part. And here is the step-by-step guide how to work with our app. First things first, you have to take a photo of a real plant. Then it will display you a name, it'll get your name, and it'll get you a short description on a map where it locates and where it grows. Once you take a shot, it will add it automatically to your library. Additionally to Scanner, we also have some challenges that teachers can make. For example, he can make a new exercise to shot an oak, and where the students get the new challenges and then just do this exercise. Students also have some streaks and rewards. The more streaks, the better rewards. And additionally, we have exam practices such as quizzes and topics. Now, let's see how it works in practice.
In our app, we have the user can be a student, a teacher, and a guest. So I'll log in as a teacher, and here we can see the class. And what can we do is create the task for the students to complete. And here I'll just put some records. And
This is your mobile phone.
yeah, it's on my phone. So the student can see the task that's been put up. So he can also see the sample image, and we can not only see that we can take the photo for the class, but also we can just take any photo for this matter. So I'll just take the photo that's used for the task. So we identified it as the Brazilian jasmine, and it shows as well where it grows. And we can claim the mission points and open it in the collection section where it will be shown here. And yeah, other plants that we've collected as well.
Take a picture of that plant. The other plant.
Yeah, yeah.
Not on the desk. Not your plant, the other plant.
Oh, yeah, of course.
If it works, I give you my lab. Did it?
Oh.
Ah, well done, guys. Amazing.
Yeah.
That wasn't planned, honestly.
It was a plan, but it wasn't correct for the task.
No, that was a plant. It wasn't planned. But
oh. Probably it's too realistic. Yeah, also in this app we have quizzes, and just also then the student also can prepare for exams in the other section as part of the learning. So here will be the explanation of the material that's been laid out here. And you can also test yourself there. And yeah, other than this, there's the profile where you can see the statistics, choose the profile picture. So everything that you want to change here has been you can buy with the points that you've earned. And you can also see the achievements here. Yeah, that's it.
Thank you. Do we have any questions?
Yeah, I'm sorry, we're actually not finished. Yeah, I'm sorry. So I just want to sing something. So about the substitute. So we swapped the boring textbooks for scanning real plans and swap the hard exams, so it'd be more quick and easier for the students. Also, we make some fun social apps, things like streaks, profiles, and rewards with the real school content. Also, we borrowed some ideas from the apps that the students currently using. It's Kahoot, online website with the quizzes, daily streaks, and the collecting plans and as a game. just modify the more levels random questions, so it's never the same, but just turn some achievements also. And who can use this? It's not just for the students. All those things can be used by the farmers or just by the people to get to know some names of the plants if they wanted to. Eliminate, we try to take the unnecessary stuff, so there's no sign up needed, no hard words, costly code trips, so just open up and scan. And reverse, so we try to flip it around so you can go outside and explore, then learn the theory and use it so the teachers can set fun challenges instead of just talking.
Who can use it? You ask me. I'll tell you that basically everyone can use it if they need. Some people sometimes need to just identify what's the plant they're looking at, like my colleague just did. I'll say it's pretty useful. And out of all people, I can really highlight teachers and students. Teachers, with our app, teachers will really easily encourage their students to learn and learn physically. Go outside, see the grass, I would say, just see the plants. Yeah, and the farmers that work outside on the fields, they will really sometimes need to use our app. And pretty much, I'll say, how would we make it better in the future? We thought about that, and maybe if it's possible, we could collaborate with the local shops or maybe, I don't know, cafeterias, something like this, and make the points that students make more valuable for them. Maybe they can spend it on some lunch or something that will make them feel that they got reward. We could add more competitions like higher-end quizzes, class-to-class quizzes, like just live competition. And we thought about stepping on a new stage, maybe adding soils instead of plants, like not instead of plants, but more to plants, like add soils to identify soils, or maybe even animals if it will be necessary. And it's really gonna make process for teachers easier, I would say. And yeah, that's probably it. And just fun, I would say, and easy, and it works. Thank you.
Thank you, sir. Okay. We'll have one.
Just very quickly, well done, guys. You actually showed how it worked, which you kind of weren't supposed to do, but anyway, it gave you a little bit of an advantage. And you also answered in that last minute what was going to be my question, which was, what was the fun element? But I just want to throw this out to you. What if you're dealing with the school in an inner city where they really don't have access to any plants? How would you deal with that?
It doesn't matter where you live. For example, you can bring the plants from the countryside and then just take a pic. Like, for example, we bought this plant in Lidl, so we didn't find it anywhere. For other examples, it could be made by any other photos. Like, for example, you have a friend or family who lives in the countryside, and they can take a pic of this photo and just send to you. And you can just upload it with our app, and then we'll get you the same results, and you'll get the location where it grows.
Good answer. Thanks, guys.
Thank you.
Thank you.
Okay, now the jury can discuss it for a couple of minutes, and we wait for the results of our hackathon. Okay?
is, I was looking for Professor Nastas. Please come with us. We have with us Professor Nastas, who is the coordinator of the project EU-CONEXUS Enables. This hackathon was a part of EU-CONEXUS Enables, and she is with us to do, together we'll do the awards. Okay, so we will start from the head team, and the jury decided that, please sound, okay. Synthesis Rhythm is the third place. The second position is for Agri Bloom. And now our winners. Plant Dex. Thank you all for being here. And now some food is available at the purifier. So let's move there, at the purifier. Thanks, everyone.